Hello, everyone. Welcome to the AI Agents Hackathon live streams.
The AI Agents Hackathon is a free virtual hackathon running from April 8th to April 30th.
We're hosting over 20 live streams where you'll learn how to build agents using various Microsoft technologies. At the end of the 3 weeks, submit your project for a chance to win fantastic prizes.
And now over to our friends at Reactor.
Hi, everyone. Thanks for joining us for the AI Agent Hack. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is recorded. It will be available to view on demand within 24 to 48 hours. With that, I'd love to turn it over to our speakers for today. Thanks for joining.
Hello, everyone. Good morning, good afternoon. Welcome to this session. I'm Davide Mauri. I'm a product manager in the Azure SQL team. I'm focused on developers and AI. And today I'm here to show you how you can build an AI from scratch. First, using T-SQL only, so you can understand exactly how an agent works behind the scene, then moving to use the semantic kernel to do something a little bit more interesting and more realistic, and just taking advantage of that fantastic library that is semantic kernel to basically make your agent come alive. Because this session is quite advanced in the sense that I assume that you are familiar with vectors and vector search, so that kind of concept, that you're familiar with embeddings. So you already know how to get embeddings, how to store embeddings into your database, and Azure SQL as a new vector type that allows you to store embeddings and search for embeddings and vectors in Azure SQL and also in the forthcoming SQL Server 2025. And then, of course, you have familiarity with LLMs and prompt engineering, at least a little bit. And then in general, where you take your prompt, pass it to basically an LLM to search for a specific answer given some information that has been provided through the prompt or through semantic search in order to feed the LLM model with as much contextual data as possible is something you are already well aware of. Now, with that in mind, let's see what are the problems with this RAG pattern, because RAG is fantastic when it comes to find similar content given some approximate request, like, I like semantic kernel and I want to build a solution with C#. What kind of help can you give me to do that? And maybe you want to also use some code that you have indexed in your database, or some information that you have indexed in your database. And that where is RAG is really, really great. The problem is that, let's say you have a database of examples, and you want to find the most correct example, giving the answer that you can see, given the question that you can see here, or in this case, let's say you have a database of video games. Show me all the products in the category video games updated in the last 3 days. Or, given the previous sample, show me all the code examples that has been created in the last week on semantic kernel. Well, that requires a very specific answer, and RAG cannot answer that today. And the point is that you need to move beyond RAG and actually have the LLM create a correct SQL query for you and execute that, right? So you need to move beyond RAG. And usually when you do that, you want to start to have a kind of a more complex situation where you have, yes, RAG on one side and similarity search, but also the ability to create, like you are seeing right now, a query and execute it on your behalf by the solution that you are building with your LLM model. And basically, you're moving towards something we call AI agents or agentic RAG, where you have a much more complex, even, well, maybe not that much more complicated, but definitely a little bit more complex workflow. So you have, first of all, you have your question, the question that user is asking. Then the first step, it must be to analyze the question and understand if that question needs to have a semantic search in order to find the most kind of in-scope solution or data for answering that question, or it's a very precise question and you need to have a natural language to SQL. So if you go with the semantic search path, you of course get the embedding, run the vector search, and then move the result to the LLM with your prompt, with the prompt engineering part, with the system message to define how the LLM should behave. And basically, this branch, the right branch, is really the most common RAG pattern you can see. But now you need to enrich it with also an L2SQL, which means in case the question is very precise, like show me the last 5 samples that Davide did on semantic search, you need to generate a SQL query, in our case, run the SQL query, and then again feed it to the LLM prompt as you were doing for the traditional RAG pattern, so that you can move to have this kind of conversation with your AI model. So this means that you have to take some decision, have a first step that where you ask an AI model to analyze what is the right path, and then you can apply the RAG pattern again. So how do you build that in SQL, and why you want to do that? Well, 2 reasons why you want to do that. The first one is a very good exercise to understand how agents works behind the scene and how you can build one on your own, so you can even better appreciate libraries like Semantic Kernel. But the second reason is also that if you are modernizing your application, or you don't want to use yet another library to build solution, you can do everything inside a storage procedure in SQL and basically allow existing application without any need for heavy code changes to become more modern, more AI aware, and just provide a better experience for your users. So let's do that. In the first application we are going to build together is a sample application that allows you to search for samples using AI and SQL. And as you can see, I am using Azure SQL here that is communicating with OpenAI to do the basically the RAG pattern, so for the embedding and for the LLM part. And then I'm using Data API Builder to expose my storage procedure as a REST endpoint. And then I have a very simple React application that basically used the REST endpoint exposed by the Data API Builder to interact with the end user in a nice and modern way. The website where you can actually see the sample in working in the real world, and also you can access the repository behind the scene, is this one, ai.awesome.azuresql.dev. That's exactly what I'm going to use right now. So let me close PowerPoint for a second, open my browser, a new browser window. Here we go. And let's go to ai.awesome.azuresql.dev. So what I want to do here is search, and let's, I already have a test here. So let's search for this kind of example. So let me show you that you can ask, like, show me the sample that Davide used during the AI agent hackathon in April 2025. So this is a special kind of request that you do to a machine, because the machine needs to understand your language. Like, so you are really talking with an AI model. But we want to be able to do this kind of request as long, and of course this will take a few seconds because we need to interact with the LLM. But we also want to be able to do more precise question, like show me the most recent sample of 2025, right? So how do we build something that can handle both? And in this case, you can see that right now I have some examples that unfortunately are not strictly related to the AI agent hackathon I'm presenting right now, because of course I haven't informed yet my LLM and my samples that those samples are actually used in the session I'm giving right now. So at the end of this demo, we will also update my database so that we can inform the LLM that these samples are in scope for this request, and then you see that the LLM will be able to give a more precise answer. Okay, let's start from here. Let me move to show what happens behind the scene when I ask for a question, when I click on search. When I click on search, the find samples endpoint is called, right? So we have this data API REST find sample path. And behind the scene, thanks to Data API Builder, you can see in the Data API Builder configuration that it configured here is mapped to the web find sample storage procedure. So now what we can do is start to take a look at the storage procedure. So this is the website, this is the repository behind the website. How do you access this repository? Is super simple. You just click on the little GitHub icon when you are on ai.awesome.azuresql.dev, and you will be brought to the GitHub repository behind the scene, and then you can just clone it. And that's exactly what I did. And as you can see, you have basically the full solution here. You have the front end in the client library, in the client directory. You have the database. That's the one that we are going to use right now. And the backend is basically not there just because we are using Data API Builder behind the scenes. So you don't have to build anything. You just have to configure the object that you want to be exposed from your database as a REST or graphical endpoint. So we are interested in the find sample in the find samples procedure. So let's take a look at this find example procedure. And what this sort of procedure is doing, of course, is taking the text that contains the question that you have asked. And the first thing it's doing is transforming the text into a vector, right? So by basically asking an AI model, more specifically an embedding model, to take the text and convert into a vector. And then is searching in a table that I use as a semantic cache to see if someone already asked that question before, because in that case, we don't need to generate a new question, a new answer. We just take the question from the cached one and take the related answer. So ideally here, we are just trying to spare a little bit of money when in resources, instead of calling LLMs, complex LLM models, we can just take what we cached. Let's assume, of course, in our case, that the question has not been asked already, so we need to generate a new question. And the first thing that we do is orchestrate a request. Now, remember that we said that the pattern needs to change a bit. So the orchestrate request is basically this analyze section here, because we need to figure out if we need to do a semantic search, so using vector search and whatnot, or build an L2 SQL query, build a query for us. So let's take a look at the orchestrate request procedure. Let's start with the simple one. And basically, the orchestrate request, again, take the text that we are that the user is searching for, or the question that the user has asked, and then start to build a payload to be sent to an AI model, LLM in this case, a ChatGPT, GPT-4o LLM. And basically, we are telling to our AI model that it should behave as a SQL Server database assistant, and the question that has been provided should be used to create a correct SQL query based on the table that I define here. So I'm telling my AI model what tables it can use in order to answer the question. In this case, I only have one table that contains the samples I want to search. And basically my tables, it's very simple. It has an ID, the name of the sample, a description where you can describe your sample, some notes like in which conference has been done, what language has been used, and so on and so forth. Just like the details, using in this case a JSON structure, for example, the author or other information, and then when it was created and when it was updated. This is really my sample table here, right? So if I go here and I do a select star from dbo.samples, you will see that I already have plenty of examples here that basically contains the information you would expect such a table to contain. And in a few seconds, you will see the results. And here we go. Okay, so all my samples, the name, the description, again, the notes, additional notes, plus all the information like, for example, the author, the language is used, the license, what services are involved, and so on and so forth. All this information are vectorized, are turned into an embedding when I create my example, so that then I can use a vector search to search into all these columns with all this data, and then properly provide this data here that you can see highlighted now to the LLM to complete the RAG pattern. That's exactly what is happening here. So I tell to my LLM model, first of all, figure out if you can answer the query that has been asked, answer the question that has been asked, creating a query using this table. If you can't, because maybe you realize that you need to search into the notes and in the details, and so you feel like you should use a like operator, well, stop and don't generate the query, right? Because it means that we need to switch to a semantic search where we will do vector search and all the other stuff. But in that case, you want to use the second path, right? So if you feel the need to use a like query, you probably want to go to the right path where you do the semantic search. If you instead can use a very precise query, like a where clause, where I don't know, creation date greater than something, then you are in the NET to SQL path. So the first step, the orchestrator, has only one goal: to understand if the results can be used using a SQL query or using something else, so not a SQL query. And once the orchestrator is done, we have a result that tells us, yes, we have a SQL query generated that contains the query that needs to be executed in order to answer the question. And in that case, here I'm just doing some lightweight check to make sure that the query doesn't contain anything harmful. Of course, the check should be a little bit more deep and complete, but in this case, just to show you that you need to do this kind of validation to make sure that the agent doesn't create any crazy query. And then once we are happy with the query, we execute the query that has been generated for us by the AI model. Because remember, the orchestrator request decides if the question can be answered with a query against this table that I defined here, and if yes, it will generate the query. Otherwise, it will say none, and there will be no query provided. But if there is a query provided, we just have to execute the query, and that basically will contain the result for the question. If not, if the query is not provided, because again, there is some semantic search that needs to be done, so the orchestrator decided to go for the semantic search, then here we just use vector distance and find the most similar example to the embedding generated by the query, the question generated by provided by the user. So we find the most similar example given the question using the embedding behind the scene. And then basically, again, here in this case, I'm also using full text search to do a complete hybrid search here. And then we get the result, and we send the result to the LLM model here in the generate answer. So basically, the find samples call the orchestrator to understand if you need to run a SQL query or if you need to run a semantic query. It runs both the queries in order to have the results generated, and those results will be provided to complete the RAG pattern. And the completion of the RAG pattern is done in this story procedure called generate answer. So basically, we are back here. We are now in the section where we call the LLM with a full prompt and ask for the answer given the question and the context we provided. So let's go and take a look at generate answer. That is very simple and straightforward and aligned with what you probably expect already. So here we just take the query. So the original question that the user asked, the samples we provided and we found using either NET to SQL or the semantic search, and then basically we provide the full prompt here. So we say to the LLM that you are an assistant who helps user finding code samples and so on and so forth. The samples are provided in an assistant message using a JSON array, and then we move to explain, in detail how the AI model should behave given the question and the answer we are providing. And we provide the found examples in the system message as regular in the RAG pattern. Again, the question that the user asked. And then in this specific case, I'm also using a structured output to make sure that the output of the LLM will have a very well-known schema. So I want an output that has a result position, an ID, the sample summary, and the thought. So once the output is generated using SP invoke external REST endpoint, because we are calling the LLM as a REST endpoint, then I can simply return the result. And once the result are returned, I can basically just use OpenJSON and convert the result into a table and then join back with my original table. So it's very nice because here I have the LLM called generating the result and joining the result back with my full table to provide the most complete answer. And this is pretty nice because, for example, I can well, first of all, let me show that I delete the cache so you can see the fresh result every time. But basically what I'm going to do right now is execute the storage procedure just like it was executed before through the UI, but in this case from Visual Studio Code, so you can see how it works behind the scene. And then we can peek into the semantic cache to see exactly what happened behind the scene, depending on the answers and the questions. So perfect, the semantic cache is cleaned, so there is nothing cache right now. And so if I go and test my first query, like show me the sample that Davide used during the AI agent hackathon, let's execute this one. And what is going to happen right now is that the first LLM call is deciding if to answer with a SQL query or with a semantic search query, executing the queries, and then sending the result to the final LLM to complete the RAG pattern. And as you can see, it's nice because the result is actually a table that is, or a result set that is very easy to send back as a JSON payload to my front end, and then nicely showing the UI. So what happened behind the scene? Let's take a look at the semantic cache. It also helps us to see exactly what happened. So the question asked by the user was this one, the one I typed before, and the decision by the AI model, by this orchestrator here, where the question was analyzed, was to run a semantic query using this text as the text to be used in semantic query. So the query was vectorized. The results were compared against the embeddings already stored in my database, because if I go to vbo.sample, actually I have the table here. For example, we can get sample embeddings. So let's take the notes. Here we go. So here you will see, let's do a top 5 from, you will see that I already have created the embeddings for the nodes of the related samples, right? So this represents the embedding for the sample number, for the nodes in the sample number 6. So if I do select a star from bio.sample where ID equals 6, the embedding that you're seeing right now are calculated on these nodes here. So in order for me to do the vector search when needed. And this is exactly what's happening right now. The LLM model is running a vector search or a semantic search, getting the results, and those are the results that embedding search generated. And then this result has been passed to the LLM model to complete the RAG pattern, and then this is the final response of the RAG pattern, which is a JSON response that can be easily turned into a table here, thanks to the fact that I'm asking for a structured output. Now let me show you what happens if we instead ask for something more precise, like show me the most recent sample of 2025. Here I would expect a query to be generated because there is no need of doing vector search here. So the AI model is thinking. So we are again in the analyze phase right now. Then in this case, the AI model will decide to go and create and run a SQL query, generate the result, and then pass everything to the LLM to complete the RAG pattern. So here we go. These are the latest 5 examples that I created. And how do I know that? Because if I go in the semantic cache and see what happened behind the scene, you will see that this question has been answered with a query. And let's see what query has been generated for us. It's a select top 10. from the samples table where the year is 2025. Very nice. So this is the query that has been generated by the AI model for me, and then it's just working. Okay, so that's basically quickly how you need to build an agent manually. So you need to build, first of all, a moment where your agent understands and decides what to do. Then it implements the solution, then run the solution, gather the result, and then connects to the second LLM to complete the RAG pattern. Just to show you also how nice it is when you run it on a relational database for operational RAG, is that let's say that those are the samples that I added to basically put the examples I'm showing to you right now in my database. And when I created these samples, at that time, there was no AI agent session going on. So what I want to do right now is add this event where I'm presenting right now to the information in my sample. So I'm adding the fact that this sample has been used at the AI Agent Hackathon 2025. So both the one that I will be showing in a second and the one that I'm showing right now. So let me add it here. Nice. So let me basically do an upsert of my samples. And when I will run the samples, what is happening is that I'm not only updating my database, but also generating the embedding for description, for the note, and for all these details. So then, so that the semantic search can properly, search within all the updated data. So let me execute this. And what will happen when this is done is that I can go here and ask again the same question, and you will see that this time the question will actually return the only two samples that I'm actually using here in this session. So I updated my two examples, so I can take exactly, well, and actually, you know what, we can just first of all run this here, and then we can move to the website. Let me delete the cache to avoid to recycle the answer I had before. So delete the cache. Now the cache is empty. So I can go and run my sample again. And before I had more than couple of results, but this should return only two results. And specifically the AI examples I'm discussing right now and the one that I will be discussing next. Perfect. So now the AI and the semantic search knows precisely that only these two samples are the one related to the session I'm presenting right now, because I added the information about the event in which I presented this session. So that's very nice, because this allows me to update my data in real time. And as you can see, without even changing my application, I can, thanks to the fact that my agent is built within the database, I can update the knowledge of my agent and make it a little bit more complicated or more refined without having to redeploy the application. So let me now execute ask this question here also. And you see now that the answer, first of all, is super fast because it's cached. And second, now I have exactly the right samples. And the explanation is that, yes, this sample was used during the AI Agent Hackathon 2025. So this is exactly what you want, right? So that's very nice. Now I can even remove a little bit, show me the samples used. Again, this will most likely reuse the cached data, because the question is very simple, very similar. So I'm using semantic caching to also make sure that I don't call LLM models, which are quite expensive for every single request. If I want to make sure that the request is fresh, I just need to delete my cache here. So let me go here, and you can see that now the cache was filled. Now let me delete that. And let's go back to the website, search again, and you will see that now it will take a little bit more time, because now it needs to, again, go through the same process here. Analyze the question I'm asking, figure out that semantic search is needed, run vector search, pack the result, send it to the final LLM for completing the RAG pattern and getting the result. And here we are. So very nice, very powerful, I would say, because it enables you to build agent right in the database without having to install any extension, any library, whatever. So it's very powerful, very useful to learn how agents work behind the scene, especially this process. But it's now time to move to something more complex and realistic that involves, now that we have clarity on what an agent does and how it works, involves semantic kernel. Because the reality is that, yes, it's fantastic to do everything from T-SQL, but if I'm building a new application, maybe I want to take advantage of libraries like semantic kernel. So I have a nice demo here where I will basically show you is how you can create an agent following exactly the same principle. So telling an agent which tables it can use, telling an agent to kind of analyze, first of all, the question in order to answer the right with the right approach. But before going to that, let's take a look at the second, how this autonomous agent actually works. And basically, this agent needs to have a goal. They use LLM to understand the end reason on what to do, even before doing it. It has some memory and some context. It can use tools, in our case, functions, and of course, can communicate with other agents. So the example I've built, even before Semantic Kernel added the new agent support, which, by the way, this sample is not using yet because I just need to update it with the latest and greatest semantic kernel updates, but it shows anyway an agent, even if I was not, even when I built this example, the term agent was not yet fully used. And the agent works in the sample works in this way. I'm building an agent that has the goal to help a human to do its work as its best. And specifically here, I'm thinking an insurance agent that needs to meet a person and needs to understand what's going on with that person. So I am, let's say I'm this nice human agent here. What I think the AI model should help me to do is to bring agent. What can you tell me about him? Now, the AI agent, the first step needs to orchestrate the request, right? So the orchestrator will simply say, well, first of all, we simply think, actually, where I can find data about customers. And as before I fed to my agent the information about the schema of my database, this orchestrator agent will have the same information. And in addition, this agent will also have information about the tools that it can use in order to access that data. So, for example, the orchestrator agent will have information about the fact that there is a database and there are some tables, the customer table, the claims table, the policies table, that can help him or it to find details about a customer. Now, this orchestrator agent only see the high-level detail of the table. It doesn't really know how the table is done internally. For example, the active policies may be saved in a JSON column or in a JSON document. So that high-level agent, the orchestrator, only have high-level information on what is where, like what kind of data is contained in this table or in this database, but no more. But it has a kind of holistic overview of what is in what kind of data is available in the data estate. Now that he knows that there is one place where he can go and find data about policies, claims, or any other information, he needs to figure out what tools or what other agent can help to find that data, because the agent has only high-level knowledge of the data. It doesn't really know how to query the data. So basically start to ask, hey, who can help me here? And there are other agents in the same application, in the same solution, each one specialized to get data for that specific set of information. Like, for example, the CRM agent will inform the orchestrator agent that it knows how to query the CRM data. And for example, this is what the CRM agent will actually see and what can access to in terms of context information. The CRM agent knows exactly how the table is done, how to query the table, the fact that, for example, active policies are stored in a column called details, that is a JSON column. So the agents, the specialized agents, has very, very specialized knowledge on how to query their own data. And so this is true also for the claims agent and for the payments agent. And basically now what the orchestrator knows is who to ask to for help to get some specific data that he might need. So after the first question, the orchestrator agent figures out that he needs to query the customer data. And so he needs to connect to the CRM agent and say, hey, can you give me the details about John Doe? Then the CRM agent actually creates the query like we saw before with the samples table and run the query, the correct query, and return the data to the orchestrator agent. Now the orchestrator knows that John Doe is ID 123. So he can go to the claims agent and say, okay, can you give me details about the customer 123? And can do the same for the payment agents and so on and so forth. So at the end of the process, the orchestrator agent, which is the one that actually interacts with the human user, has all the information needed to answer. So for example, as information about the customers. Now, one interesting thing from this table is that we have a customer with the same name, but of course, different IDs. So the customer, the agent needs to figure out also how to disambiguate between these three different customers. And also there is another interesting to note here before moving to the demo is that some of the information are available through a storage procedure, not through a table. Because let's say you have a table called communication history that contains information about all the communication that happened in the past with your customers. So they've been transcribed or stored from email received, so that you have a complete overview of all the communication that happened between you or the agent and the customer. Now, this means that here you need to do something like a RAG pattern. And let's say that you have created your RAG pattern using the sample I showed before, where you have your storage procedure that does all the complex stuff. So you want to make sure that you have a storage procedure that runs vector search in this table. And that storage procedure can also be used by one agent to actually run the correct query. So you can really choose if you want to expose a table to the agent or a storage procedure or function or view. It doesn't really matter because the agent is able to use them all. In the samples that I'm going to show right now, it's available here. Again, another GitHub repository. And I think it's something you really want to share with your managers, your bosses, your colleagues, because it's pretty impressive. And so let me get to it right away. So let me go here and do .NET run chat. And I'm enabling the debug mode here because I want you to see what happens behind the scene. So every query that you will see running is because I have enabled this debug mode. Of course, in the real world, I will not allow the human agent to see the queries happening behind the scene, right? Because they don't need to know all the complexity behind. But as a developer, it will be interesting to see when I ask something, how the AI agent will actually behave by or talking to other agents or running a query for me, right? So this is now connecting to the LLM models and loading the long-term memory that I already have filled with some information about my fictitious insurance. And then while this is booting, I can also take some of the sample prompt that I already prepared, and we just get started. Hopefully it will boot soon. Today we had some networking issues. Here we go. So let me ask the question. I'm the human, as you can see from the icon, and I want to talk with my agent. And so let's just ask, hey, I'm meeting with John Doe later today. What can you tell me about him? So the agent start to think and say, okay, I need to, query the table. And this is probably the query I would do, given my high-level information of all the data that I have, but let me ask to the specialized agent to actually run the correct query. And well, I was good because the query I had in mind is exactly the query that also the more specialized agent decided to run. So perfect. I have the information about the customers. And of course, 3 customers are returned. So now the agent tells me, hey, you need to be more precise because there are 3 customers. So let's say he's in Redmond. And now the agent can go back and call all other agents and ask for the claims, ask to the payment agent for information about the policies, and so gather all the information I need to provide the answer to the first question, like I'm meeting with John Doe, what can you tell me about him? So here I have the details about John Doe, and that is great. Now John Doe wants to meet with me, probably for some reason. So maybe I want to look into the discussion history, in the communication history that we had between us and John Doe. So I can ask, is there anything specific? Is there anything that I should know about past communications, maybe about price increases? Because I know that insurance has been getting more and more costly. So probably John Doe want to discuss with me about that. And that is right. John Doe had a recent communication regarding, so this agent is actually going into the communication table and doing vector searching there. And as you can see, in this case, the agent decided to search within that table using a storage procedure I provided with the price increase subject. So literally, the agent were able to either run a query for me or to execute a storage procedure in order to get the correct answer. This is pretty amazing because then I can say they can do many more complex queries. Now let me clean. So first of all, with this example, you can also see the whole history between what went on between the various agents and the details. But let's try to clean the memory of my agent to pretend I'm starting the application from scratch, like in the morning. So what I can do is simulate the fact that it's not that my interaction will always be, hey, I'm meeting with John Doe, and the agent will ask me, okay, can you tell me which John Doe? And then I answer from Redmond. Sometimes at some point I have the agent ID available for me right away. So the agent, the customer I discover is John Doe. So I can just say, hey, can you tell me if John Doe, and then we can say customer and its number complained about price increase in the past. So we can just go straight to the point, providing all the information needed in the question, like I would do with a human, right? And again, in this case, is running the same procedure before, because clearly the question is very similar. And I see that John Doe is expressing concern about price increase on several occasions, and then I can read all these occasions. Okay, now I have more information. Now what I want to do is, ask for, okay, thanks, like I would do with a real person or with a real agent, right? How many policies has John with us? So let's try to understand if it's a good customer, is a new customer, how many policies. So now the agent is going and query the policies. But again, all these, so it has 7 policies with us. So pretty nice. So show me the policies. And you can see now that it shows all the details, all the information about the policy. So I can ask, is John Doe a good customer? For example, whatever it can mean, right? But it's interesting because what I want to show is that once you build an agent and allow the agent to communicate with other agent, and you have this orchestrator, this kind of a consultant that use other agent to get more information about specific topic, you can clearly see a human starting to communicate with AI agents in a very natural way, right? And again, right now I'm showing what happens behind the scene, but you can just use this application without the debug mode, and you will have the real experience that a real user will have when talking with the AI agent, right? So here I can also say, is there anything that could help me to make John happy and keep him as a customer? And so in this case, for example, this is providing some generic information, but I can ask I can inject in the memory of my agent memories, if you want, about maybe, for example, special rates or special discount we can apply. So is there any special program or discount I can use with John to reduce the costs, the premiums, for example. And so now the agent is looking in its memory I injected. And yes, the agent now helped me to discover that there is this safety score program that helps a user that is a good driving habits to monitor the driving and define a quality of the driving, and then provide a discount based on how good you are at driving. Maybe you are a very good driver, so there is no point in asking you much money, because it's very unlikely that you will be involved in issues. So this is very, very nice. This is everything done with Semantic Kernel. And let me just give you a quick glimpse of the code here. So everything is basically in the chat. Class where I'm using Semantic Kernel to add plugins. And now again, I will probably rewrite this to use agent instead of a function and plugin. But basically, I have my functions here. As you can see, I am describing each method in this case, what it can do. And here we go. For example, this is basically an agent built manually, because when we only had functions available, not agents, what I did here is create a function that internally calls an LLM model to generate the query here, right? So you still have a orchestrator, and then each function here was actually calling was a sort of a LLM model on its own, capable of querying and extracting information by the policies. Now you don't need to do that, because you can use the agent, which is a little bit simpler to build, but the concept is very similar. So you have this orchestrator that then use other agents or other tools in order to get more insight and more specific information on something that the orchestrator agent may not have all the information, all the detailed information needed. So he's asking help to other agents or to other tools. So in this case, I'm telling this agent capable of querying the policies table, what is the policy table, how to query it, and so on and so forth. In this case, I kept the prompt very simple, just to, again, for the sake of simplicity and keeping the example straightforward to understand. But please make sure that to download this example and try it for your own. Now, the question that I see here is, what happens if the underlying schema changes? This is a great question, and keep in mind this is an example, and I put the schema here just because it's easier for me to explain to you that I'm exposing the metadata in the prompt. What you should do is actually not unless you really want to kind of take a snapshot of the schema, but what you should do here is, instead of typing the schema yourself, imagine having a functions that go to the database, gather the table schema, and inject it here, right? So again, this is an example, and that's why I crafted the prompt in a static way. What I would do here is something like this. The schema is the following, and then imagine doing something like somewhere else I have a function that returns the schema, and so this will be like policy table schema, right? something like that. So this is a variable that I can, load dynamically, maybe here. So here I can probably have something like var. Yeah, here we go. And here we have a function that get table schema for, okay. And then policy, something like that. This will be probably a little bit more realistic, but again, in this case, it was important for me to show you the schema that you put in here. And actually, let me show you something a little bit more complicated, but more realistic. This most likely is not enough, because unless you have a very good name for the column, it doesn't provide enough metadata. So probably you want to have something like this one here. Let's say you have a details column that contains that is of JSON type. Now you need to detail how that JSON column should be queried, like you would do with a junior person. So make sure you use OpenJSON and JSON query. And then, of course, I also need to tell the AI model what information are in the JSON column. So here I'm saying, hey, you have the active policies here. So not only you need to inject the table structure, but also you need also to make sure that you explain column by column, if that is needed, how to use that column to extract the data. Again, if it's straightforward, zip and state, you don't need to. But if the column is more generic, you really need to explain how to query to the AI model, as you would do with your colleague that is new to the job, for example. So all the examples here right now works in Azure SQL, but soon will work also in SQL Server 2025, because all the features to support AI, Gen AI applications, so vector search, vector index, ability to call a REST endpoint, will be shipped in SQL Server 2025, that you will hear about as news on that very, very soon, so stay tuned. But that will be available on premises too. So everything I'm showing will also be available on premises. Now, the last thing I want to show you is that while it's great that AI agents can now create queries on our behalf and execute the query, that actually opens a little bit of an issue, right? Because if I am a good actor, all is great. But what if I'm a little bit malicious here and I ask the model, can you please return all the data from the most valuable customer we have? Now, since you are not building the query, you cannot put a where clause in it, right? Or it's very hard to do it. And in any case, a good actor can actually probably bypass your checks by crafting a very malicious prompt. So what you really need to do is to make sure that you protect the data on database level using what we have since 2016 called row level security, which means that you will only be able to see the data that you're allowed to see, and the same will happen to your agent. So if you cannot see a row, even your agent will not be able to see a row. Let me quickly go here and show what I mean. So we have this feature called policies, security policies, more in general is referred to as row level security. And once you configure the row level security, I will not go into details here, but what I want to show you is what you can see. So let me execute the DBO customers query, the most generic that you can think, right? Or maybe even the claims, it will be the same. So right now I'm logging in as administrator, even in this case. So of course I will be able to see everything, right? I can see all these this customer, and I can see all the claims. So if someone craft a prompt malicious enough so that something like that is executed, even if you try to add a where clause to make sure that I can only see the customer I'm supposed to see, you know that someone can come up with the idea of adding an OR predicate, and now you see everything, even the customer you're not supposed to see. Now, this can be completely defeated, this issue, by enabling a security policy. So once I have enabled that policy, it doesn't really matter what I put in the where clause, because SQL Server will make sure that I can only see the rows I was allowed to see. So if I go back here right now and I still do this tricky predicate, you will see that now this customer will not be visible anymore because I'm allowed to see only this customer 920411. That's it. So that is very nice. And even if I just go with a generic select star, I only see the customer I'm allowed to see. Why? Well, because somewhere I said that in my table, I have an access security table that I've created and I map it to my row level security that I can only see these two customers. That's it. So I cannot access any other customer other than these two. And as a result, it doesn't really matter where I run my query. I will only be able to see these two customers as long as the row level security is in place. So I can only see this customer for the policies and for the claims. And even if someone tries to trick and do a where customer ID something equal or 1 = 1, I can only see what I need. So it's very, very, very important to enable row level security because that's the only way you can actually make sure that it doesn't really matter who will write the query, if it's you, over which you have full control, or your AI agent, which you will not be able to fully control. So the query will be the query that the agents wants to run, but it doesn't really matter because you always protect your data using row level security and make sure that you never leak any potential data. My examples are done, so I'm right on time, and so that's basically prevent the issue. So I see a couple of questions. One on the fact that today SQL Server and Azure SQL only supports up to close to 2000 vector. It should not be a problem. So if you go to devblogs.com, and you can find, and I'll share with you in a second, this blog I wrote. Let's see, let me find it. I think it's even older, on how to choose how many dimensions you should choose. So this is the one I'm sharing with the team here, so it can be shared with you. But the point is that, yes, we have 2000 dimension limits. Some model generates more than that dimension, like 3000. First of all, you can shrink that dimension number to a more manageable. And not only you can, but my point is that you should, because super big dimension doesn't really change the quality that much. So for example, if you have 3000 dimension, the average performance on 55 dataset used by this well-known embedding model benchmark is 64 points. If you take the same model and turn it down to 20 to generate only 226 dimensions, so basically 1/10, you only lose 2 percentage points of quality. So you have a huge improvement in terms of space used, performance, in just much easier management, because 3000 dimensions are really large. It's like 12K for each row, and you don't really lose much precision and quality. So my point is, make sure that you use the right number of dimension, and this article can help you to figure out how to decide, because otherwise you're just wasting space. And space and means IOs and more CPUs and less performance for actually no practical reason. With that, I am at time, just a couple of minutes over, since we had some networking issues at the beginning. I hope that the stream went well, and the slide deck is already available. The samples, both samples are available, and if you go today now to the ai.awesome.sql and just search for the samples that I showed during the AI Agent Hackathon, you will actually get the right results already. So just do that if you don't want to remember all the URLs. Let's see if there are... So I see a question here. Speaking of custom where clauses, how do we address potential SQL performance issues if a subpar query is being generated by a specific agent? For example, like that was a good catch, because my query generated was converting a column to a year instead of doing a between clause. You exactly tell the agent how to behave. So in the prompt, you will go, in this case, the sample was here, and you will go in the prompt where you actually generate the query. So this one, orchestrate. And here you will explain that you should never apply a function to a column, but try to move the logic to the static part. So you can also make an example saying, for example, if someone asks you to extract the year, do this and that. And this is what is called a few shot prompt. So you can also specify some examples that the AI model will use. And the model will generalize that also for month or for days in this specific example. So basically the answer is as you need to have a very good prompt. So that's why today there is a lot of discussion on becoming good at prompt engineering, because the quality of the SQL will be directly proportional of the quality of your prompt. And the more specific you are, the more detailed you are in what kind of query should be generated, like you would do with a very junior people, the better that person will be able to generate the query for you. Okay, hope that makes sense. I'm well over time right now. I don't see any other questions. So thanks a lot for following the session until now. And I really hope you will continue following the AI agents hackathon and have fun with it. Thanks a lot, everyone. Have a great day or night or afternoon, whatever. Bye-bye.
Hi, everyone. Hope you enjoyed today's session. If you aren't registered for the AI Agents Hackathon yet, register now at aka.ms/agentshack and start hacking on the agent of your dreams.
And if you have any questions along the way, just post in our GitHub discussion forum or attend our live office hours in Discord. And of course, make sure that you keep attending the live streams to keep learning about agents.
Once your project is ready, submit it before April 30th at 11:59 p.m. PT to be eligible for our prizes. Thanks for joining.